Here's an example of a problem number 6 type of difficulty out of 25 problems on the AMC8. This is a question about swimming pools. And if you have ever gone swimming, you have noticed there's a lot of water in a swimming pool. Do you know how long it takes to fill and to drain? It's very important to drain because otherwise the water will be very dirty after a while. Here is an example of a pool which has 14,400 gallons of water. The AMC8 is an American competition, and so the units of measure are American units. A gallon is approximately 4 liters. This swimming pool is draining, and there are 4 pipes that will take the water away. Each of the pipes drains at 2.5 gallons per minute. How long will it take for all of the water to leave the pool? Measured in days. So this is a question where the main challenge is to convert between different units and also to understand what the question is talking about. You see, if there's all this water, the speed is 2.5 gallons per minute. We want to know how long it will take to come, and you have to remember that there are 4 pipes. So we start to multiply some numbers together. 4 pipes, 2.5 gallons per minute, means that every minute the number of gallons that are draining is 4 times 2.5. 4 times 2.5 is a nice number. This is 10. Again, these numbers are our friends, and the more we see these, the more quickly we realize that 4 times 2.5 is 10. So what that means is that there are 10 gallons per minute. Now, in this question, there are 14,400. This is good. Dividing by 10 is easy. And so what this means is it means that it will take 1440 minutes to drain. Now I just need to convert from minutes to days. To convert from minutes to days, I then need to know how many minutes are in one day. Well, the number of minutes per day are 60 minutes in an hour times 24 hours in a day. And if you multiply these together, what you find is 60 times 24, I can do it this way. If I take 24 times 60, 6 times 4 is 24, 6 times 2 is 12, plus 2 is 144. Oh, it's the same. Actually, I chose the numbers very carefully on purpose. One of these nice facts is that the number of minutes in a day is 1,440. That's a nice number for many reasons. One of the reasons is that it involves the number 144 inside. And I'm sharing all of these methods because when you're doing a problem, if you're multiplying a lot of numbers together, you should expect to see a number that has lots of factors. 144 is made of 12 times 12. Actually, the 0 puts another 10. And 12 itself breaks into 2, 2, and 3. So the reason that you see numbers like 144 and 1,440 appear often in these problems is because you're usually multiplying many things together. This is actually how I often try to make sure I'm not making a mistake. Because if I'm multiplying things together and I get a number which is unfamiliar, which is strange, that I haven't seen before, then I start to wonder if maybe I made a small mistake. This 144 is very special because it has many different factorizations that you will see very often. I want to share just a few of them just to finish this off. 144. You can sometimes see it come from 2 times 72. The place where this might happen is in an earlier problem in this AMC set. I introduced that 72 is a common number in geometry. If you take a regular pentagon, like this, 2 times 72 actually is this angle right here. That's 144. That's one place that you see 144 come out. And another place that you see 144 come out sometimes is this 4 times 36. 4 times 36, this is a particular nice way of seeing it because the 4 and 36 are both perfect squares. And so sometimes you're putting together 36s, also because 36 is a nice number. If you ever put 4 of them together, it should be around 1. It should be 144. There are other 144 factorizations, which come about very often when you're doing these problems. It's also 3 times 48. This also comes because 48 is very common to see. 48 is one of these numbers that has 2s, 3s, 6s, 8s. It has lots and lots of factors inside. Of course, you're also used to seeing 144 come about from 12 times 12. But there are even other things inside here that you will often see. 144 you can also write as 6 times something. In this case, this is 6 times 24. So again, these are very common types of numbers that you'll multiply together. And so just to know that they always come to 144 is useful. 8 is another way of building this. 144 is also 8 times 18. So if you, for example, are ever dividing 144 by 8, if you get a number that doesn't seem to have enough factors, then you have made a mistake also. Actually, as you can see, there are even more factorizations. I can keep going. 144 can also break into 9s and 16s. This 9 and 16 is 3 squared times 4 squared. I mentioned already there was a way to make it from perfect squares, like 2 squared and 6 squared. 2 times 6 is 12. 3 times 4 is 12. So here are all these different ways. How do I know if I have all of the different factorizations? Well, one of the easy ways to see that is to say that I'm trying all of the factors. I'm not writing the 1 times 144. That's too easy. But here's the 2 times something, 3 times something, 4 times something. There's no 5. 6. There's no 7, 8. Here's the 9. There's no 10. There's no 11. And of course, there's 144, which is 12 times 12. As you can see, there are so many different ways of making this 144. And that's actually why you'll see it come across very often whenever you're doing these kinds of problems. At the end of the day, just remember, if you're doing a problem with minutes and days, 1440 is actually a way to see how many minutes there are in the whole